Have you ever worked on WebAssembly in Rust and you had to use WSM bindgen and you thought of, I don't want to use it. What are the abstraction it does provide and can I write a code without it? Like how hard it could be to write a code without it. So today I was just exploring this question and I have some interesting results and I thought of sharing it. And moreover, the thing is, after this video, you will actually come to respect what it does provide. So, yeah, this is WSN in raw Rust by Piyush Raj, and you are up here. So, to write a WSM like WebAssembly code without WSM bindgen, you have to ditch it. That's it. That's the first step. Like, really. And then, when it is ditched, you have to create a project. If you don't know, it just looks like this. Yeah, that's a beginner friendly tutorial for you. Many people told me that I am not giving a beginner friendly tutorial, so up here. Okay, so now coming up next, once you have your project created, you know there is cargo.toml with you and you can just add few things to it. You have to add those two lines to cargo.toml and there is that create type. So if you're a little bit familiar with toolchain, how Rust builds things, you might know that by default it builds in a rlib format, which is like a Rust library, and it can be used only with the Rust code. You can have a static binding kind of thing. So it's not useful for you. Okay, it's not that much useful for you. So if you want to produce something other than that, you want to use cdy lib create type. That's it. And with that, if you have that crate type and you provide a particular toolchain, maybe a Linux toolchain or Windows toolchain, for Linux it will produce your .so file, for Windows it will produce your DLL file, and of course for a WSM it will produce your WSM file. So we are specifying which toolchain we will be using in the .cargo/config.toml. In that you have to add those two lines. Yeah, it's simple. Once you are done with this, you can go and check your lib.rs. Your lib.rs have some code, and by default it comes with add function. I don't know why. Who just thought of adding an add function, or maybe it's a primary thing which will work for everyone, I guess. Like whatever thing you are making, maybe you are making no standard or something like that. I don't know. So it's like a beautiful starting point. So once we're done with this, everything is set up, we are all good. And I think now we can build, and that's your like you can do a cargo build dash that's release. And with that, I guess let's add some JavaScript, I guess. Sadly, is it really like all good? Like, is that our function was added? That's the question. So if you just use a particular toolkit, that is a WebAssembly bandit toolkit, in which you get WSM to VAT format, where it is like a WebAssembly format, like it looks like a assembly kind of thing. Yeah, you can just see there is that example. This particular example, it's a WASM, VAT, WT, VAT. So we can see that just like with a little bit of highlighting, we can see that first of all there is table memory, there is a stack pointer, there are some global like sections, I guess, that represent sections, and then there is a memory, then there is a end, data end, heap base, and things like that. But we don't have a add function. Like, where is the add function? Can you see? Is it like if you might have done any kind of assembly kind of thing, you might know that you will always have some label. Like, once it is compiled, it will have some label, like particular label, and that label would be called. And there is no label for it. There is no label for it. It's not like a plain assembly, it's a web assembly, so it will also have things like function and table. You can see there is a table, so it's like a cool advanced kind of thing. For now, just that's we have got. So what we have to do to get that add function, we have to say the compiler, a compiler, you are mingling with mingling, what you call mangle, you are mangling with my function. Like, you know what does mangle mean? You have to say no mangle, man. Hey compiler, don't mangle with my function. So what does the mangle mean? Like, mangle mean like destroying a particular thing completely. It's a very harsh word, so I think that you have to just say that, hey Rust, hey compiler, this is my function, why are you mangling with it? Don't mangle, man. And I think you have to use it. Like, there are cases where you have to use it, and this is a particular beautiful use case for you where you can use no mangle. And with the no mangle, and this is the particular code, like a little bit different what we added. And with that, once you produce it, and you can see there is that function appearing. One or like few of the things you must like notice, actually you must like notice. First of all, there is the label for our function, okay, and then there are the parameters. We did pass two parameters, left, right, you remember, and those parameters are local, get one, get zero, like the name also is given with that. Also, moreover, if you just like look a little bit, the id of our function is also given, there is a type and things like that. There is also a result, like which is the return type. The function will take two integers and it will return a integer I32. Please just concentrate that we haven't used something like I guess you just need to see this particular thing. We haven't used, hey, where is that gone, man? Yeah, we haven't used like something like I64 or U64 like that, or maybe U32, some weird data type. I shouldn't say weird. Actually, they are very specific data types which WebAssembly support by default. And if you just do some kind of here and there, you might have to use big integer and you might get some kind of error of types. So please focus that it's a U size. You can use U32 instead of this, or I32, or if you want to use float, you can use F64. Other than that, please don't use anything else because it will be a big mess for you. Yeah, so not a big mess, you just have to add n if it's a big integer, or if something else you have given, just please note that okay, you have done that. Okay, after that you can see there is a export add. That's like export, you whenever you write a JavaScript code, you just have exports. Similar way, there is this export which just exports add function. So now let's everything is good and we can write a JavaScript file as we were planning, and here is our JavaScript file. So a few things to notice. First of all, there is this import object. These are the objects which will be given to the WSM, okay, and the WSM can use it. Like WSM can actually use it to just like there could be function. WSM can call those function and use the JavaScript code inside it. One of the cool thing you might will be willing to know is WSM WebAssembly code. Whenever it is executed, it have a like a sandbox. Like the browser says that okay man, we have something hot. Let's just run it into the sandbox. I don't want to give access to everything outside this world. When you can't even just use console log without specifying it that I want to use console log. Okay, and that's the thing, that's how it works. There have to be like some kind of sandbox, so it have sandbox, and that's the thing, that's why we have import objects. And yeah, you can pass, we'll see how to do it. For now, just see, we are reading the file, and then We are creating instance of it, instantiate WebAssembly.instantiate. You are giving the data and the import object, and once all that done, you can see instance have exports. We were exporting in our previous slide, and it exporting 22 like that. No, not 22, I'm saying it's exporting actually add function in which we are giving 20 and 2, which just sums up to 22. So yeah, we are doing a console log. So with that, let's move forward to the ABIs. ABI. So actually, what is a ABI? ABI is a application binary interface. Yeah, full form. Full form is that. It just means that whenever you have an application written, you can communicate to that application. Okay, and for that there have to be some kind of interface. Yeah, you know API, ABI. Yeah, just imagine like that. You have some kind of thing like that. Like just read this line. I just copy it, paste it from Wikipedia, I guess. An application binary interface is an interface exposed by software that is defined for in-process machine code access. Often the exposing software is a library and consumer is a program. Easy. There is this library, there is this program, they can communicate with each other. How? The program can call a function from the library, and that's how it works. This is ABI, application binary interface. Yeah, think of it as a API for libraries. So once we are done with it, we need to understand that we cannot use Rust ABI by default. Like Rust have a Rust ABI. By default, it comes with a Rust ABI, and we cannot use Rust API. Why? Because it's like unstable. If you just Google it or something like that, you will just find out that it's unstable. But why it is unstable? Why do we call it as an unstable thing? Because it have weird things. Like just imagine in C++ or C, if you just create a structure, the uh, it does matter what is at the top, what is at the bottom. Like it is the first thing is A, then B, then C, and they have different data types. For example, up here, just see, we have this. I guess I have a little bit of database, like data type just being misplaced. uh, just look at that. There is A, then there is B, then there is C. A is 8, B is 16, and C is 8, and like that. So in Rust, whether you write it as a ABC or ACB, whatever, that doesn't matter. Okay, while if you do that kind of misplacement in C, you will end up with B getting stored in C, C getting stored in B. You're getting me? So if you just switch it, you can see if you just switch it, it will just switch the places. You're getting me? If you in C, it's like a flat binary being laid off, and in which there would be section for A, section for B, and section for C. If you just write C's value in B instead of writing it into the B, like it's like a memory location kind of thing. If you don't put it correctly, it will just get misplaced. So Rust does allow those kind of thing, and we don't know, man. Like, hey Rust, why you are doing this kind of thing? She be like, oh, what kind of drunk guy is he? He don't even know where to put where what thing, and he thinks like everything is okay. Just level is what we want to match. We cannot do that for now. So to make a Rust ABI or C ABI, what we have to do is we have to do a great work. We have to add extern C. Yeah, that's it. Yeah, really, that's it. Just a keyword with a C, and that C tells it's a C ABI. Do we have different ABIs? Go ABI maybe? I don't know. I really don't know. I don't have idea. I've just worked with the C ABI, and it's today only. I did use FFI before, but I never created a FFI myself. Instead, I have used it. Okay, so let's come back to what we have to do. Once we have like AVI all good, and we like, what else we can do? We can maybe use JavaScript in Rust. We want to call some JavaScript function in Rust. We just talk about it. Object, yeah, in the first script only we just saw. So to do it, we have to add extern, like extern section, and add a function. That's it. And then we have to tell what it links to, like WSM import module, name of the module, the math is the name of the module, and then we have a function like fn random. So yeah, doing this you can use a random, and you can see we have used unsafe block for it. Okay, all good. Now what you have to do is, in the import object, you need to add the math. We just saw we wanted math, we wanted random, and this is the random function. And yeah, don't ask me why we have used math dot random. It's random. So doing this, what it will do for us, what the great thing we get random numbers being added to our 22. Isn't that cool already? And we have like play WSM being called with, I'm using fish. No complaints about fish. Fish is a great cell. And yeah, that's it. Fish is a great cell. I use it. So we are running this particular program 10 times, whatever, and it just prints it out. Cool. So the question is, we are using unsafe here. So do we have to use unsafe everywhere? The answer is no. The answer is really no. You can have one more function like a wrapper function which will call unsafe instead of calling unsafe everywhere. So it's just a pattern kind of thing. It doesn't have anything to do with like what people do or something like that. It's just a way to do it. So I've created a math module in which I have the math.js. Yeah, so we have created a math module in which we have the math.js module, and that have now our unsafe random function. And what cool thing we are doing is we are calling that unsafe random function into the random function which is inside the math, and then we can simply use the math random. Does it become safe? The question is that, does it become safe? Well, everything outside this block is safe. Please note it. If you're like not familiar with the unsafety of the Rust, because many people think that Rust is completely safe kind of thing. Not really. Rust is not completely safe. It just gives you like a border between what is safe and what is unsafe. So inside this, if anything fails, then it fails. We cannot do anything about that. Well, you might ask me why this is unsafe? Why do you think it is unsafe? Because uh, the first of all, we don't know if the TypeScript will provide us with the random function or not, or JavaScript will provide with a random function or not. Second, maybe the JavaScript's random function have some issue. Maybe it's doing some memory leak. You might be worried like, oh my god, how a JavaScript function can give a memory leak. We cannot trust the interpreter. It's written in C, C++, Rust, whatever language. We cannot trust the interpreter, and it will be from there it's coming to the WSM. And if you think that, oh my god, like why it is coming out of the interpreter of JavaScript and then to the WSM, why can't we have it directly from JavaScript to WSM? JavaScript is not meant to write a compiler or interpreter, and if we were writing a interpreter in JavaScript for WSM, it's like the whole purpose of WSM is gone. It's made for say for like fast, like speed. We want speed. That's why we have WebAssembly. And if you don't, and if you're interpreting it in the types, the JavaScript or TypeScript, whatever, it's slow. It's slower than the JavaScript then. So that's it. That's why that's unsafe. That's why the things are bad. That's why the thing is like that. Now let's talk about the higher level types. There are two types of types. Yeah, like Rust have two types of types. Although we can divide it in different ways, but then we have like two types of types. Yeah, there is something called as sized type and there is something called as unsized. I don't know why they just write it unsized as question mark sized instead of writing it as unsized. Yeah. So first of all, just look at the size type. Size type. It have like two types. I just heard that there are two types, but now there are four types. But that's three types. Don't get confused. We have the tree. Don't confuse with my language. Just the thing is that look at that thing. See, whatever is, be simple, be cool. Uh, if you have a higher level types are structs, arrays, strings, whatever, like whatever can be stored in the heap or thing like that. Like whatever can be stored in the heap, easy. Whatever can stored in the heap, like into int and bool is not something like higher level type. Okay, so higher level types have two types, sized and size, and then there is that first of all, like higher level types are converted to pointer. Ask me why? Why it is pointer? If you work in C, you will see the array is a pointer. You will see struct gets into a pointer. You will see like union becomes a pointer. And I don't know if there is more higher level types in C. I know of only three: struct, union, and yeah, there are. I guess there is enum. Not sure enum. Enum is I guess number only, numeric type only. Yeah. So leave the enum. I don't know about enum for C. Yeah, in Rust, enum is like a higher level type, and enum is very. I guess it will be very difficult to just pass enum from WebAssembly to JavaScript. So first of all, the thing is, whatever like there is a size type, it will be converted to a pointer. Okay, and that pointer will point to the data. Okay, cool. Now another thing which you want to know is, if there is a return, it will return a pointer. If it is a parameter, it will take a pointer. If the size of parameter is like, actually that's written, yeah, that's written actually, I guess it's written wrong. Uh, I I just forgot. Yeah, see, the thing is, if you have to return, see, if you have to return a data larger than 32 bit, then the return type itself becomes a parameter. That's what I had to write, and I have written something else. Yeah, just I was just making notes, and it's my notes. So if a return type, if you do have a return type which is larger than 32 bit, it will become a parameter. You If you use C, you will notice that we don't return like pointers everywhere. We, instead of returning pointers, we take pointer. Like if you have to write to a buffer, we don't return a buffer. We give a buffer to the function, and buffer writes it, like the function writes it on the buffer instead of returning a new buffer. Why? Because that like deals with some kind of dangling pointer, I guess. Yeah. uh, Instead of confusing yourself too much with the pointers, like when it get dangled, and if it's like very complicated big logic, it can get dangling pointer. So that's the thing. What are the unsized types? Rust have only mm, it will be a very like big statement to make. I think Rust do have Not only, I don't know if that's the only two, but Rust do have two unsized types. First is the dynamic trait, and then there is that array without size. Okay, slice. Yeah, so slice doesn't have size. For a dynamic, just not slice itself, I should say generic slice, maybe something like that. Yeah. So be very sure. I'm very sure about is the dynamic type, like dynamic trait. Why so? Why so? Because if you just look at the implementation of dynamic trait, it's like doing a dynamic dispatch. Uh, Easier words, it's using polymorphism. You have one particular function which can be from multiple object. Based on the runtime decision, it will call the function from particular object. So to do this, Rust use something called as a fat pointer, thick pointer, I guess, fat pointer, whatever. There are two pointers. Simply, there are two pointers. One is for metadata and one is for the actual data. There is a v table made. It's like a complicated thing, something for other video. Yeah, just imagine there is a v table. There is a pointer. This is pointing to a v table. Then that is pointing to some function. And yeah, I think this is a thin pointer kind of thing. But fat pointer would be a little different. So when you have a like unsize type, it will return you like you will you will like get two parameters. You will get two parameters, one for metadata and one for the actual data, metadata, actual data. Cool. So once we are done with that, man, don't ask me to implement any of this. It's very difficult, very complicated for to be honest. Maybe later, for not for today. So the question is like, do we have STD, standard library? Let's explore it. Just do we have a standard library? We are using thread and boom, we don't have. Easy. Yeah, when you do something like this, it's like unreachable code should execute, blah blah blah, things like that. It's saying that something is being called. Just look at the output. Bunny is saying like I should not. Yeah, like the JavaScript is saying something is being called which is not unreachable code. The code is not reachable, and that code is not reachable. Like it calls add and it says that hey, add this too. Then the add is calling thread and things like from STD. Then the WSM is like I don't know where is this STD, and that STD is like that. Like imagine that situation, a whole panic, the situation of panic. So that's how it is going. Rest the WSM is saying, I don't have HDD. I don't have. Where is the HDD? HDD is gone somewhere. And then it tells the JavaScript, HDD is gone somewhere. And the JavaScript is like, HDD is gone somewhere. So, no, we cannot use it. So, is Rust fooling us? Well, not really. Since the CDOI lib is made to be compiled for multiple tool chains. It doesn't have to be the WSM tool chain. So no one knows whether you can use the STD or whether you can't use the STD. Are you getting me? No one knows whether you can or you can't. So the overall thing is no, you can't. For this situation, for maybe other situation, you can. Why it's so? Why we don't have STD? The simple answer is since we are in the sandbox of a web browser, and we don't have access to libc, we don't even have access to std. Sounds very weird, but you can make a std, but then what are the input output? Like why to have a whole std with you when you can without it? We sound very weird, but yeah, that's the truth. The sandbox doesn't have STD for us, so STD environment, you don't have like threads, you don't have things like that. So yeah, Rust is not fooling us, it's just not telling us. So we can make it no standard, and with that, first what we have to do is we have to add that particular line, the no STD in front of it, and then we have to add the panic handler. Yeah, add the panic handler. These are the two things we have to do, and with that I have the whole code. And once you do this, if you add this thread again, and then there only you will get from the Rust analyzer itself. I just copy paste the warning from the Rust analyzer that the failed to resolve the use of unlinked crate std. STD is unresolved. Sounds funny, but yeah, we don't have STD now. That's the thing. Since we don't have STD, we will get the error, and we cannot use STD things. And it's like sacrificing STD. Like, say, I want warning at the compile time itself. I don't want it at runtime. Okay, no runtime panics. Yeah, and what about this panic handler? Can we improve it? Surely, you see, these two are kind of the same purpose. It's like unreachable. I think it does halt or maybe loop. Whatever, I'm not sure, but yeah, it does something. Then finally, since we don't have the STD, we don't have heap. That's the problem we talked, like we did discuss before or itself. So since we don't have heap, what are the things we can't do? We can't allocate vector. We can't use vector. Uh, you can see there is this error down here, no global memory allocator found. If you write this code, and please just see this slash slash, it means there is some code above, some code below. So what you have to do is you have to declare your global allocator. See, first of all, I did try to write my own allocator, and it was a complicated thing to do. I was like, I need to think a little bit about it. It's like using a data structure and pages kind of thing. I had approached like I want to make a array and then allocate in that with offset, but then I did realize that I to reallocate or something like that, I need to actually keep track of already allocated spaces. Then things got a little weird. Then uh, nothing much, I got already written allocator, which is that valloc. It's easy, simple. Valloc, the WSM enabled elfin allocator. Don't ask me what is this elfin. I just copy paste it from there. Read me. Okay, it's alligator. Easy. Don't make it too weird. Okay, so done with this. All cool, all good. You can have like num state and you can add to function to it. And this is the final output we got after like the whole day of thing. Well, I think this made some sense for you, and this is the whole summary. Thank you.